So hello everybody, welcome to this first video about integral calculus, which is a branch of calculus that likes to look at the accumulation of change and is essentially the opposite of a derivative. But the first thing we're going to look at, this basic concept, is something called area under a curve. Now, why is this important? Well, this is important because it allows us to find the original function from a rate function. To understand this better, let's look at an example. Well, here we have a graph which shows the velocity in meters per second on the y-axis and time in seconds on the x-axis. Now, when we find the area under this curve, if you've taken Physics 1, you'll know that this is position. If you don't know why, it's because if you take the units of velocity, meters per second, and you multiply it by the unit of the x-axis, which is seconds, you get meters because the seconds cancel out. So what I've essentially done is I've multiplied the units of the y-axis times the units of the x-axis, and that gives me meters. And basically, anytime you're finding the area under the curve, the unit of this area is always going to be the units of the y-axis times the unit of the x-axis. In this case, this gives me meters. So by finding the area under this velocity versus time graph, I can find the position or the amount of displacement, the amount of distance this object may have traveled. So in this example, from seconds 0 to 2, let's say it moved at a velocity of 4 meters per second. So if we find the area of this little section here, that will essentially be 2 times 4, which gives us 8. And once again, these units are going to be in meters because 2 here is in the seconds, since it's the base of the rectangle. And 4 here is in meters per second, since it's the height of the rectangle. And like we proved down here, when you multiply the units out, you get the desired quantity. Now that gives us only part of the question because we still need to find this area here. So how do we find this area? Well, as you can see, it's in the shape of a triangle. As we know, a triangle has an area of 1/2 base times height. In this case, this base here is going to be about 1 because 3 minus 2 is 1. And the height is still going to be 4. So if we want to find the area of this triangle, we're simply just going to do 1/2 times base times height, which gives us 2. Again, meters, because as we had in the last one, this one is from time. This 1 represents seconds because 1 is the base of the triangle, the difference between 3 and 2. And this 4 represents velocity, the height of the triangle. And meters per second times second gives you meter. So now we have these two areas, 8 and 2 from this rectangle and from this triangle. And if I add these up, I'm going to get 10 meters. So what I've essentially done is actually taken a very simple integral. I have found the area under the curve that gives me a new quantity denoted by the y-axis multiplied by the x-axis. Finding the area under this curve gave me the distance this car traveled, which happens to be 10 meters. This is a simple explanation to integral calculus, and really this is what integral calculus is all about. Because here we have a rate function, and we're trying to find the accumulation of change. As you're accumulating position here, you're accumulating distance as your velocity changes over time. And that is a simple explanation, intro to integral calculus.